You like honey? Yes, honey. The golden liquid that so many of us enjoy in our tea or on our biscuits. Worker bees leave the hive in search of their food, nectar. A bee will drink this nectar to fill their honey stomach, which is where the honey making process begins. Enzymes in the bee's stomach begin to convert the sweet nectar into honey. This process repeats as the worker bees return to their hives and regurgitate the contents of their honey stomach into another worker's mouth. This exchange occurs several times within the hive before the bees achieve the sweet product they're known for. This digestion process breaks down the polysaccharides found in nectar into monosaccharides found in honey, like fructose and glucose. Honey also has a very low water content, a result from bees beating their wings to create an air current that evaporates the honey's excess water within the hive. Aside from sugar and happiness, honey contains some other key components such as gluconic acid, 9 essential amino acids, several enzymes including glucose oxidase and catalase, and volatile compounds such as benzene and derivatives of it. Honeys collected from different plants can also contain unique components derived from that plant. For example, manuka honey, which is made from the nectar of the manuka tree, is known for its high methylglyoxal, otherwise known as MgO content. Honey tastes great, but what's really amazing is what it can be used for outside of its flavor. It is widely recognized as a natural antibiotic and anti-inflammatory agent. One of the main components of honey's antibacterial activity is its hydrogen peroxide content. Honey produces hydrogen peroxide mainly during glucose oxidation. This reaction is catalyzed by glucose oxidase, an enzyme found in bees. Hydrogen peroxide can break down cell walls and thus kill bacteria. MgO in manuka honey also has an antibacterial effect, even in the absence of hydrogen peroxide production. MgO content is manuka honey's main antibacterial component. It prevents bacterial growth by damaging cell structures such as flagella, fimbriae, and the cell wall. Some honeys have displayed such strong antibacterial activity that they have proven effective against methicillin-resistant Staphylococcus aureus and E. coli. And in addition, compounds called phenolics and flavonoids suppress inflammatory activities. There is also evidence that honey promotes wound healing when applied to a wound. Honey prompts leukocytes to release cytokines, which begins the process of tissue repair. So it really is no wonder that honey has been used for millennia around the world for medicinal purposes. From treating cataracts, wounds, and burns to sore throats, infections, and a bad gut, this golden elixir has proven useful in more ways than one. Even today, medical-grade honey has been tested as a component in bandaging wounds and fighting antibiotic-resistant bacteria. I, for one, am very excited to see what the future of honey in medicine holds.